All right, so now we're going to talk about networking. Our objectives are basically for you to understand how basic networking functions inside of AWS. We're going to talk about the difference between a public subnet and a private subnet, meaning the difference about whether it can get to the internet or not directly, or whether the internet can get to it, right? Which is also the difference. Most of us, by the way, in our houses, we run private subnets. We can get to the internet through, NAT translation, but by default, the internet should not be able to get to us directly, right? We're also going to talk about ways in which you can connect your data center up to AWS, and then a couple of layers around security, like firewalls that are in place for AWS. Okay. So imagine you're in a coffee shop, you're supposed to talk to the cashier, and someone cuts the line and talks directly to the barista and says, hey, can you make my coffee for me? Typically, you don't want that. That's not how that's supposed to work. This, in a thought, is basically how private and public subnets work. Now, let me explain this further. You walk into a shop, right? What happens is that you want to create an isolated space where services happen. So in your account, you might want to create segments. These are network segmentations, where like product A is in its own kind of isolated network, product B is in its own isolated network. That's known as a VPC. And so let's say product A is in coffee, and what you want is you want people to talk to the cashier, but you don't want people talking to the barista unless the barista is delivering something to you. This concept of having a front end and a private back end, that's how networking could work. So a subnet is a section of a VPC that is a deeper slice of the networking information. What do I mean by networking information? Well, like most of us are running 192 addresses on our home networks or 10 addresses on our home networks. When you create a VPC, you have to give it an IP range, and a subnet is a portion of that IP range. So that's all subnets are, is they're just slices of this overall networking pie that you've created. Now, a subnet can be private or public. What determines whether or not it's private or public? Well, does it have a connection to the internet or doesn't it? And when I say a connection, I mean a direct connection. Now, with a public subnet can get to the internet, and the internet can get to it if the firewalls allow it. Now, just to be clear, by default, at least one firewall is on at all times with AWS. And you have to explicitly say that you are going to allow the internet to talk to that service. AWS will not by default launch an instance and then open it up to the world. So you are totally protected from the internet, even if you're on a public subnet, unless you go in and open up that firewall and say, hey, by the way, the world can get to me. And that's on you. Okay, so be mindful of that kind of thing. So here, the client is hitting a particular DNS name, which goes to an IP address, which hits an EC2 instance on a particular subnet. And it has to run through a virtual object called an internet gateway. That internet gateway, by the way, provides practically unlimited bandwidth out to the internet. Now, obviously, you pay for anything that leaves AWS, but anything you want to put in AWS, they're not going to charge you for. VPCs work region-wide, meaning they eat an entire region. They do not go multi-region. Subnets, since they have specific networking information attached to them, subnets can only live inside of a single availability zone. So subnets are not going to span multiple availability zones. If you want to work in three availability zones, you have to have 3 subnets. You want to work in 6 availability zones, you got to have 6 subnets, one for each of your availability zones. So the difference here is that if you're in a private subnet that doesn't have direct internet access, how do you make it so that your corporate network, for example, could get to your private subnets? But you're like, Michael, you just said it didn't have internet access, and that's true. It does not have direct internet access, but you can use this thing called a virtual private gateway, which will allow you to hook your VPN services at your corporate data center up to AWS, and that in turn will allow you to talk over the private encrypted connection it creates. It'll allow you to talk to your private subnet inside the VPC. So this is an interesting state of affairs, because while the private subnet doesn't have access to the internet, using a virtual private gateway, you can actually run a VPN connection over the internet and use that to get access to your private subnets. Now, that's an over the internet option. If you're like, Michael, I need something more secure than that, I don't want to run my traffic across the internet, you can use something called Direct Connect, which allows you to run a physical cable from your data center to a router inside of AWS's partner location, and they in turn will allow you to connect that router directly to a wire, basically, that runs over to AWS. So this allows you to either use VPN, which I know all of you at Booz are familiar with, right? Because you use VPN all the time, versus a direct cable. Now, let me be upfront about this. This Direct Connect connection can run at sub 1 gigabit, 1 gigabit, 10 gigabit, and 100 gigabit speeds. So this is fast. It's not encrypted by default, so you have to enable encryption if you want that to happen. So it's a little bit more private because it's not running over the internet, but just be clear, it's not encrypted. You have to encrypt it. So 2 ways to get your private access to your private subnets. Either use a virtual private gateway using VPN, or use Direct Connect. Either one is fine. Just depends on your compliances. Okay. Well, let's do a little challenge to match some components here. If you want to isolate databases that are on a private subnet containing customers' personal information, which of these 4 networking objects or constructs would you use to make that happen? You don't want it to have access to the internet. You don't want the internet to see it. Where would you put it? Good. Put it on a private subnet. That's exactly right. Databases in general should not be on the internet, just FYI. You probably knew that already. 2, if you want to create a VPN connection between the VPC, the virtual private cloud that's inside AWS, and your internal corporate network, how do you create a VPN connection? What are you going to use? What's the device you're going to use to make that happen? Good. It's called a VPG, a virtual private gateway. Sometimes you call it a VGW. But C is the right answer. Good. If we want to support a customer-facing website, which means we have to put web servers so that the internet can get to them, which of the 2 remaining constructs would we use? That's right. We would use a public subnet, right? We would place our web servers out there and just let them talk to each other. Now, I got to tell you, that's the kind of the old way of doing it. We wouldn't do that now. We'd actually stick a load balancer on the public subnet, keep everything else private. So keep that in mind. And then the easiest one, because it was the only one left, is establishing a dedicated connection between on-premise data centers and the VPCs, right? That's going to use Direct Connect. That's going to be use the physical cable. Okay. So those are the core components. You got a VPC. You got to make subnets inside the VPC. Those subnets can be private or public. The only difference is that can that subnet talk to the internet gateway, which means the internet can talk to it, or can the subnet not talk to the internet gateway, and therefore the internet cannot see that subnet. And then you have virtual private gateways, which are used for VPN connectivity. You also, by the way, can use virtual private gateways for that Direct Connect connection as well. So that's the physical cable. All right. Moving on, let's talk about firewalls. Okay, so this is interesting. So when a packet comes in, it's got to flow from the customer space, right down this way into the internet gateway. And then it's got to get past a firewall that literally sits around the entire subnet. That firewall is called a network access control list, a NACL sometimes in the short. Oh, sorry, go back. Then what happens is that traffic has to flow past into the security group, and the security group, again, just to make sure this is clear, sits around the entire virtual machine. And then traffic is then going to go from the security group, it's going to hit the virtual machine. And if traffic's going to return, it's going to have to go through the same process. So like NACLs, for example, have to have both inbound and outbound rules. With a security group, you just need to have an inbound rule and you're good to go. But this NACL right here controls the entire subnet. The security group controls the entire perimeter of the virtual machine. So both of them have to be open for a particular port, like a packet to come in and hit a particular port. Okay. So be mindful that if you're having any kind of like network challenges, it's typically going to be because of this or because of this, because it's just closed off, especially for a new connection. Otherwise, it could be other things like the internet gateway, or it could be routing as an example. Now, here's a couple of distinctions to think about when we talk about NACLs versus security groups. Network access control list is a virtual firewall for the entire network. So anything in that network is guarded by the NACL. By default, a NACL will allow all inbound and outbound traffic. It will not block anything. NACLs are also stateless. What this means is it doesn't remember who you're talking to. So if a traveler says, hey, I'd like to come in, and the passport control officer says, let me check and see if you're on the list. If they might have a rule that says, yeah, you're allowed into the country, but then you're like, hey, I'm leaving the country, the passport control officer has to have another rule that says you can leave. So request and response traffic has to have two rules, one for the request and one for the response. This is a little different than security groups because security groups are a firewall around just the virtual machine. And by default, a security group will deny all incoming traffic, but it will allow the server to talk to the internet. Security groups, by the way, have a memory because they are stateful, which means that if a guest comes in and says, hey, I would like to come into the building, the door attendant's like, oh, let me check my rules and see if you're allowed. You're allowed. Okay, good. You can come on in. But then when they try to leave, the door attendant's like, hey, I already checked you because you were allowed in, so I'm going to allow you out. So security groups just work slightly differently. So remember, security groups are stateful. One rule for request response. NACLs are stateless. They require two rules for request and response. Okay. Notice the flow here. Packet hits the internet gateway, which gets routed to a NACL firewall, which then gets routed to a security group firewall, which then gets routed to the virtual machine in question. So with that in mind, someone give me the word or words that is the key difference between a network access control list and a security group. What's the key difference? Which one is stateful versus which one is stateless? NACL stateless, right? So NACL does not track request and response. It doesn't know who it allowed in, and therefore doesn't know who to allow out. A security group is stateful, which means it tracks who it said it could come in, and therefore it allows them to leave, right? Good. Okay. So then that's like core networking, and that uses like the core components that we talked about before, like so regions, right? With availability zones. So what about stuff that uses the edge locations, like things that use those little servers that were scattered all over the world? Well, there's a couple of services that use those. The first is the domain name system, which, by the way, I think is the only service in AWS that has 100% SLA. That got tested recently. And we know DNS because when we type in www.amazon.com, we're using DNS to resolve that to a computer IP address. Now, we don't see it, and it happens in milliseconds, but that's what that's for. So what happens is that when you have a customer, what they do is we go to what's called the DNS resolver. Like in my case, it's Xfinity or Comcast, right? And what that does is it talks to Amazon.com to find out, well, it talks to the root servers, then to Amazon.com to find out what the IP address is of the service that I'm asking about. That gets returned back to the browser and it loads up. Now, that usually happens super fast, milliseconds. So Route 53 is Amazon's DNS service. This is the service when you want to have tight integration with AWS, plus you just want to buy a domain name or, do kind of like failover routing or geo latency routing or other routing. You can use Route 53 for this. Now, Route 53 integrates really well with AWS, and it works strongly with CloudFront and Route 50, and obviously just the native service. You have to use Route 53 if you're using CloudFront because it's going to give you a DNS name from Route 53. Now, when you use CloudFront, you turn that on, you have to specify what your origin or source is. In this particular case, it's an application load balancer, which is going to send the incoming packet to a backend EC2 instance. So this whole thing works together to make it so that your users get these cached copies of these videos or these cached copies of these images. So DNS works with CloudFront to kind of make that happen. Now here's a little knowledge check. Which component or service can be used to establish a private, dedicated connection between a company's data center and an AWS VPC? A private wire, if you will. Yeah, AWS Direct Connect, right? So Direct Connect allows you to establish that private dedicated connection. Okay. Which statement describes security groups? In other words, are they stateful or stateless? Do they allow all inbound traffic or do they deny all inbound traffic? What's the catch here? That's right. By default, they are stateful, right? Because they're not NACLs, and they deny all inbound traffic by default. They do. They allow all outbound traffic, but they deny all inbound. Okay. Which component is used to connect a VPC to the internet? What was that little purple circle? What was the name of that allowed internet traffic to come in and out depending on whether it could talk to it or not? That's right, the internet gateway. It's a little virtual device, right? Good. Okay, last but not least, I think this is last. Which service is used to manage the DNS records for domain names? What's the name of the AWS DNS service? Good. It's Route 53. Excellent. Good answers. It went the wrong way there. Well, it's better than going forward. All right. Actually, this, I guess, would be one of the last questions. Which statement describes DNS resolution, right? What is the job of DNS? We do it in our browsers all the time. What is it supposed to do for us? Good. Yeah, it translates a domain name to an IP address. That's correct. Good. All right. As promised, that was our module. So we talked about VPCs, including public and private subnets. We talked about how internet gateways connect into that. We then talked about how we can either connect to VPCs using VPN, using the virtual private gateway, or we can use direct connect to connect things up. We then talked about how NACLs, which are perimeter firewalls, or subnet firewalls, and security groups, which are instance firewalls, differ, and how there's always one of them is always active, right? And then we talked about Route 53 and CloudFront, just in terms of how Route 53 is the DNS service, and it works closely with CloudFront in order to do caching across the world over. Anything there to ask about, or anything that I missed? Okay. So we're going to stop there.